Hello everyone and welcome. We're going to get started today. I had to re-record this because the original recording was a mess. So we're looking at taking our Fahrenheit to Celsius converter and expanding it to include a lot of other functions or methods for translating from to and from the metric system. So we're taking a look at the first one here. I think this is kind of where we left off. Yeah, it looks like I'm in the middle of editing. So this is where we left off last time. What we want to do is kind of flesh out our metric conversion library. Right now our library can only do Fahrenheit to Celsius, and we want to do a lot of other ones as well. Say we want to go the other way. We want to go from Celsius to Fahrenheit. Well, how would you go about doing that? Well, I would say maybe let's start here. And I'm going to copy that, and I'm going to place that here, and we're just going to go the other way. You're going to take this method and turn it around. Instead of F to C, complains, because we already have one of those, we're going to go C to F. Oops. C to F, and then when you're going from Celsius to Fahrenheit, you're not you don't need the Fahrenheit temperature to do the conversion. You need the Celsius temperature to do that. So we're going to change this to C temp. And then we're going to turn this equation around. A lot of people would do this, to turn the equation around is they just change everything, flip that to plus and flip that to maybe flip over this and make it the reciprocal of that, whatever that is, and call it good and think that would work. But in actuality, that doesn't work, mainly due to order of operations. So what I'm suggesting here is holding off on doing this, adding 32 until the end. So do all this first, and then go ahead and add 32 at the end. Then you'll get, I think, to get the right answer. Now, I made a couple of changes from last time that I'm just remembering. First of all, we're not going to use any package names. So if there's nothing up above this, so you got to get rid of all the package names that might appear above that. The other thing I changed was I put this 0.0 and 0.0 here just to be safe. So we use floating point math. It's especially important here. Although maybe not. No, I think it would still work. So, but just to be safe, the reason why we put a 0.0 is we want that to be a real number or a double rather than an integer, because if you do integer math, then you get the wrong answer as well. All right, so I've created this new C to F function. So I want to test it out. So our tester class, typically in Java, you have two classes that you create. Every time you create something, and then you want to create a class, or at least put in some code to the tester class that would test that new method. And here our new method is C to F. So what do we have to change over here in main to do that? Well, first of all, we're get rid of any packages that might be before the main method. And then we want to do something similar to this. We want to get the Fahrenheit temperature. Well, here it takes the Fahrenheit temperature and changes it. But this isn't very useful because this program only converts 212 to 100, and it doesn't do anything else. It'd be nice if we could just allow the user to input what the Fahrenheit temperature is rather than us hard coding it like we've done right here. So what do? Well, why don't we get rid of that, and we're going to ask the user instead, the person running the program, what temperature they want to convert. That would be much more useful. Now, as soon as we take that out, it sees that it hasn't been initialized, but that's expected because we're going to fill it with what the user typed in. Now, in order to get input from the user, we need to create something called a scanner. So you say scanner with a capital S, and we're going to call the scanner input. That's our name for it, input. And then when we say new scanner again, capital S, and this time we're going to send in a construction parameter called system.in. We've only used system.in, system.out up to this point. We haven't used system.in. Now when we do that, my expectation is that the code will break right here. If I try to run it, it won't know what a scanner is. We'll see over here as I'm compiling. It says, I don't know what a scanner is. It's pointing right there, and it doesn't know what a scanner is. Well, the scanner class is actually in a it's in a library, in the Java library. So we can just use that. We don't have to create it. We just have to tell it where it's at. Well, where is it at is the question. Well, we would say import java.util, just one L, and then we can look for the scanner class. Look at all these great classes that you can use in utilities. Some cool ones. We're looking for scanner. There's scanner. That's the one we want. Now it should be happier, I guess, when we compile. We're not using it yet. Like, again, it's complaining. We've created this new scanner, but we're not using it yet. Well, how do you use it? Well, you could say this, ftemp equals next double. So it looks for the next double in the input stream. And we have to say input first. We got to tell it that we want scanner. See, it brings up a nice list of all the different methods you can call on the input scanner. And then don't forget to put a semicolon. It will fill the F temperature with whatever the user types in. And then we use that F temperature here. Why is it complaining here? It says resource leak. Oh, we didn't close this. Yeah, if we put in a scanner, we have to remember to close it. So that always has to be last. So right before you close out the main method, we have to remember to close the input stream. So we say close. Yeah. Now it's going to stop complaining. All right. Yeah. So all the complaints are gone. Let's see if it actually runs. Well, you can't really. Can we tell? So right now, maybe or maybe not, the computer is running, the program is running. It's waiting for us to put in a temperature, although we didn't tell the user that. If we do put in, like, say, 32, we're hoping 32 in Fahrenheit is 0 in Celsius. Let's see if we get 0 back. And we do. That's good. Let's try another one that we know. We know that 212 should be 100 Celsius, so we'll try that. 212. Yeah, we get 100. But again, this isn't very good because the user can't tell what they're supposed to type in. We didn't give them a prompt or like some text to say, hey, could you put in a Fahrenheit temperature? So let's do that now. We'll try right here. We can say, now we do system.out, right? System.out.print. Notice it's not print line. What are we printing? We say, please enter a Fahrenheit, hard to spell, temperature. That's how you spell it. Maybe a colon and a space. And don't forget to put a semicolon there too, just so it won't complain. Let's see if it works now. We run it. We're looking over here at our console window. We're trying to see. Oh, there we go. There's a nice prompt. Please enter a Fahrenheit temperature. Okay, I'm going to put in, I don't know, yesterday's temperature was 81 degrees Fahrenheit. That's equivalent to 27.22222 degrees Celsius. Yeah, I don't know if that's accurate, but I don't know. If you're from Australia or something like that, that would be kind of warm. Not super hot, but kind of hot. Anything over 30 is hot, I would imagine. All right, so we've done Fahrenheit to Celsius. Now we have a nice little prompt that comes up, and we can test it, and the user can enter different temperatures. But now we want to go the other way. We put in that new method over here from Celsius to Fahrenheit. Well, what do you have to change over here to test it? Well, we've already got an F temp and C temp, so we'll use that. We already got our scanner. That's fine. But then once we get to here, that's all specific to Fahrenheit to Celsius conversion. So I like to put these little comments in, 3 of them, and then in the middle one I say test Fahrenheit to Celsius. And we're testing it, right? We have our library function, and we're testing to see whether that works. And we tested it, and it works. But now we want to do the next one, which is going the other way. It's going to complain right off the bat because there's a couple problems. First, we're not going from Fahrenheit to Celsius. This time we're going from Celsius to Fahrenheit. So Celsius to Fahrenheit. Okay. Yeah, so we're going there. And so now our input isn't a Fahrenheit temperature, it's a Celsius temperature. We're going the other way. So we're just turning everything around. Celsius temperature. That's how you spell it. Well, we're asking for the Celsius temperature, but here we're storing it in an F temp. And that's the Fahrenheit temperature. So we want to switch that to C temp for the Celsius temperature. And then instead of converting from F to C, we're going the other way from C to F, F being Fahrenheit. Passing in, well, we're trying to convert from Celsius to Fahrenheit, so we probably better pass in the Celsius temperature, not the Fahrenheit temperature. And we store that finally into the Fahrenheit temperature because this method returns the Fahrenheit equivalent of whatever C temp is going in. So that's change that to F temp. Then our output, well, we got to change that to, it says Celsius. We want to say Fahrenheit. Fahrenheit. Temperature is, and then, well, it's the Fahrenheit temperature, so not C temp but F temp. We only need this close way at the end after we do all our conversions. So let's give this a try and see if we get. See if we can test to see if it's accurate. The first test is still going to run. We don't really care at this point about the first 10, but I'll put in 100, see what that looks like. It's 37, that's hot. Celsius temperature, well, which ones do we know? We know 0 should be 32. We know 100 should be 212. So let me try 100 degrees Celsius, should be 212 degrees Fahrenheit, because that's the boiling point of water. And we did get 212, so that's a good sign. Let's test the other one. We're going to run it again. This time we're going to put in 0, and hopefully we'll get 32 for our Fahrenheit temperature, because 0 is the freezing point of water in Celsius. So we can just try that. 32, we get 0. If we put in 0, we get 32. So it works either way you do it, which is cool. Well, if we look at the assignment has lots of things we need to do. Let me bring up that assignment real quickly. So we take a look at it. I'll pull it over here to this other screen once I get to it. This is Java 1. Assignments. And here, this is open. It says available from the 5th. Yeah, so it is open. And look here what we have to do. We have to Fahrenheit to Celsius, Celsius to Fahrenheit, but then we've got all these other ones. Inches to centimeters, kilometers to and from miles, ounces to and from grams, and pounds to and from kilograms. So let's try this one. This is the one we did in class today. Kilometers to and from miles. What would we need to do to get that to work? Okay, so going back, what happened to Replit? There it is. Okay. So here's our tester, right? We're doing our test. Here's one test. Here's another test. Let's try writing our test first and then going from there. So I'm just copying this test and we're changing what we think we need to change to go from, let's say, kilometers to miles, let's say. Test, and then we're changing it a lot, right? Because we're not using Fahrenheit, Celsius. We say kilometers to miles. Okay. So please enter, what would you say here? The number of kilometers? Now we need a variable to store that in, right? We put this prompt out there, say, please enter the number of kilometers. So we need this. But we don't have a kilometers variable yet. So let's make that a double. We'll say kilometers, or if we, I like typing everything out. Some people abbreviate everything, but then it's hard to tell sometimes what do they actually mean. Get rid of ctemp. And then we'll input the next double. We're assuming that the user is going to put in the number of kilometers. We'll store that in the kilometers variable, and then we'll send it to our metric conversion lib, and we're going to have to create a method called kilometers to miles. Okay. What do we pass in as our parameter? Well, we need the kilometers as input so that we can convert it to our miles. So we'd say kilometers. And then instead of ftemp, we need miles. If we just type in miles, notice that the compiler complains because it doesn't know what miles is. Complain, compiler. I think by now it should be able to figure out that's wrong. But if we try to run it, it'll bomb right there. So he says this. First of all, there's no conversion method called kilometers to miles. That's one problem. And then here it's also saying that, hey, I don't know what miles is. You didn't tell me what kind of variable it is. What's its data type? And just like we did with kilometers here, we're going to have to say double before that so it knows what we're talking about. I like Java in that it's strongly typed, so it'll force you to say what type of variable that is. Here, we're going kilometers to miles. We pass in the kilometers. That works. And then when we print out our result, we would say the number of miles is, and instead of ftemp, we're going to print out what we calculated, which is miles. All right. If we run this, it won't run because we've only done the test part. We haven't actually created this method called kilometers to miles. See, it gets to that and it goes, I don't know what you're talking about. You haven't created this yet. So let's go create that. Now for the rest of these, instead of having a nice tidy little equation like we have from going between Fahrenheit to Celsius and Celsius to Fahrenheit, what we use instead is a conversion factor. Public static double. And we need kilometers to miles. Kilometers to miles. And we pass in a double, which is our kilometers. Now this name doesn't necessarily have to match the call. So here we call it kilometers, but here we can come up with a different name if we want. I'd say K because I'm tired of typing in kilometers. And then we have to come up with a way of converting kilometers to miles. Now notice the return type here is double, so the thing it returns is the number of miles. We don't have to state the name. So we would say return, but how do we figure out the number of kilometers that are in a mile? I know it's 1.6 something or other, but we want to be super accurate here. So maybe we just go to a website and we say kilometers to miles. Google usually brings up something like this. So every 1 kilometer is equivalent to that many miles, but we're trying to go from kilometers to miles, not the other way around. So we would say miles first. So 1 mile equals 1.60934 kilometers. Oops. It's a little bit off. It's almost 1 mile. But I think that's close enough for jazz. All right, so here, then we take that number that we copied. That's our conversion factor. And we multiply it times the number of kilometers. Well, is it really like that? We know that there's 1.60934 kilometers in a mile. So we would take the number of kilometers, k, and divide it by the number of kilometers in a mile, and that would give you the number of miles. You got to think it through in your head to see. Okay, so there's our kilometers to miles. Let's try running it and see what happens. Now, it's still going to do the other tests, right? You know, the Fahrenheit temperature, 212 is 100. 100 in Celsius is 212. The number of kilometers. Well, let's see. If I go, say, 110 kilometers, I'm expecting that to be somewhere around 68. Because I know if you drive 110 kilometers per hour up in Canada, let's say, it's equivalent to around 68 miles per hour. Let's see if that's the case. Yeah, 68.35 and a bunch of numbers. Okay. Is that accurate? Well, I suppose we could test it using this thing. If we say, if we say 110, we get 68.3508. Let's see if that's what we see. 3508. So we're off by a little bit. But again, how accurate do we need to be? If we get within 2 decimal places, then I think that's close enough. And so we would say that that was a successful test. All right. But how do you go back the other way then, you might ask? Well, it's actually pretty simple. You just copy what you have and then just turn things around. So instead of kilometers to miles, you say miles to kilometers. And we're passing the number of miles because that's our input, the number of miles, and we want to spit out the number of kilometers. And so you would say, well, here you would change that to m, I guess. But then all you have to do with this conversion factor is just multiply it. Right? Because if you have a certain number of miles and you multiply it by a number that's larger than 1, in this case, you're going to get more, right? And you know there's more, if you have 100 miles, you're going to have lots more, or relatively a large amount more of miles or kilometers in that mile. Let me try that again. Sorry, I'm sleepy. If you have miles and you're trying to see how many kilometers that is, that number is always going to be greater than the number of miles because it's the number of kilometers in a mile is more than 1. That's what we're seeing here. So let's write a little test case for that. Right now we don't have a test case. We haven't written that yet. So I'm going to grab this code and then copy and paste and then just flip it over and see how it works going the other way. So instead of testing kilometers to miles, we're again doing miles to kilometers. And then this time we're not asking for the number of kilometers as our input, but the number of miles. We're going the other way. Here, this is where you have to be careful because we already have a kilometers variable up here created because we put the word double there, and then miles is already there. So we don't want to recreate them. We just want to reuse them. So since they already exist, don't put the keyword double there. And then in this case, here we want to input the number of miles from the input stream. And then this, we want to say, well, we already have a variable called kilometers, so we might as well use it. We'll just overwrite whatever's in it. And then here we'll call our new function miles, our new method, miles to kilometers. You'll hear old programmers get methods and functions mixed up all the time. Here, what do we need as input to turn from miles to kilometers? Well, our input is going to be miles, not kilometers, so we just replace it, switch it. And finally, we'll take that number of kilometers we figured out and we'll print it out so the user can see it. But it's not the number of miles, it's the number of kilometers. So you change that one. All right. How confident am I that this will work? Not very. Typically when you make lots of changes to code, it typically doesn't run the first time. Let's see if Mr. V has been careful enough. Okay, so we have 212. We get 100. We put in 100 for Celsius and we should get 212. Number of miles, we'll say 100. Number of kilometers, 100 kilometers is equal to 62 miles or so. Please enter the number of miles. Well, we knew 68 was somewhere around 100. That's 58. 68. Let's see if we get somewhere around 100. Yeah, 109. Okay. And then the program stops. So that's basically the process. For each one of these conversions, you got to figure out that conversion factor. Use this kind of idea where you just put in one for one or the other one, and then use the other number as your conversion factor. The only question you have to ask is, do I multiply or do I divide? And then you can verify your answer using this thing. But eventually, when we're all done, what do we want? Well, we want to go from kilometers to miles. I just showed you that one. But then we also want to do inches to and from centimeters, ounces to and from grams, pounds to and from kilograms. And each one of them is going to need a test code for doing that. And so over here in the tester, again, you can see the pattern, right? We write one test, here's the next test, here's the next test. So for each method that we add, we have to write some test code for it to make sure that it works. Keep adding those right before input.close. Remember, input.close is the last thing you have to do. You only do it once, right at the end of the main method, which is right there, main, see? So just keep that pattern going. Try not to get confused. I get a lot of students that get these wrong because they forget, am I going this way or am I going that way? Make sure you recognize which way you're going. What is your input? What is your output? Keep that all in your head while you're coding it, or you'll get it switched and then you'll get the wrong answer. So I guess that's everything for today. Try to condense it down a bit. I was a little bit more longer-winded in class today, so I'm glad I'm making this video. Hopefully this will